All right. Afternoon, everybody. I'll introduce myself in a second. I wanted to say a couple of things. Last time I spoke at the conference, it was St. Patrick's Day, March 17th, back in San Diego. And it was in the afternoon. We just had a delicious lunch, and I could see the lethargy in the team. So I suggested to Lloyd that we adjourn from the main room, go to the bar. Well, predictably, he said no. Not only he said no, he said, when I ask you to speak, if you could behave yourself, that would be great. So I said, well, how about I start out with a joke? Our team, we've got an Irishman, an Englishman, a Canadian, and a Louisianan. He said, nah, leave the jokes to Fish. He's a lot better at them than you. So, no pressure there. Anyway, good afternoon. My name's Bill McNinch. I work for Lyondell. I run their project execution and construction department. I came up through the contracting route, so I know where all the dead bodies are buried. So I've been asked to introduce real-time progressing and visualization. So I wanted to start out and ask some of my fellow owners, how many times have you heard, well, we thought we were at 80% complete. Oh, and we've spent 80% of the hours, but we're really only 50% complete. Jay, does that resonate with you? Yes. And we all know that when you eventually get to 80, getting to 100 takes another 50%, right? So a bit of a challenge. How many times with installation work packages have you heard, well, we're 95% complete with them all? Well, how many complete with completely? None, right? Bit of a problem. Then in modularization, which is a really important concept that we all need to embrace, how many times have you heard, well, we've had problems getting the modules to fit with one another, right? So again, bit of a problem. So it's interesting, because the team, and when I say the team, I don't mean the contractors, I mean the team, right? As Jamie said earlier, it's win-win or lose-lose. So we all have to look in the mirror at this one. So the team never really sets out to do this deliberately. But we do tend to add up, find out the consequences later. So I got to thinking to myself, I know there's really good tools out there where we can get an idea in real time. We can actually look at models. Kevin yesterday was able to articulate about how easy it was to make a decision isometric and a spool installation from the model. Jay, I think, showed some, module builds over time, progression over time. So we know the tools are out there. So I said, well, I'm looking for some edification that this exists. So the guys here have got the hard part, and I'm going to ask them to show us what can be done. So I'm not going to introduce the team because they all know each other better than me. But here's all the handsome fellows, right? And I've got the pleasure of handing over to Jonathan from Bentley. And make sure you ask these guys lots of hard questions at the end. They deserve it. Thanks, everybody.
Awesome, thank you. So I'm going to cover the difference between a 3D engineering model and a 3D construction model in terms of moving from them. So essentially you can see the building blocks and color-coded the AWP process as we see here. So moving from the 3D engineering model to the 3D construction model happens in between stages 1 to 4, obviously beginning with the end in mind. I'll cover the 3D engineering model here next. So purpose-built, used primarily for engineering design, We can do some preliminary planning validation. We can also, go into that level of detail like we saw and heard about this morning in the AWP data requirements and build those 3D engineering models and 3D construction models with those CFOS requirements built into the model early within the AWP planning process. And that could be, your equipment designs, 3D modeling, civil, electrical instrumentation, that document control, the estimating and cost component of it, procurement, structural detailing, steel fab, pipe detailing, fabrication, and contractor scope. So as you can see, moving from the 3D engineering model, you get into the 3D construction model. So what does that mean? Well, it's purpose-built for construction. Utilizing all the information we've done in our early engineering design, detailed engineering, and now a model that is specifically for construction execution. So the 3D construction model primarily used for planning, coordination, execution of projects. It focuses on the necessary elements such as dimensions, materials, and subsequent modeling software can be used to federate all your models from multiple sources into a single 3D construction model that can be utilized within the project. We can utilize 4D cost, 5D facility and management and cost control, and then get all the way to 6D and 7D in terms of operations and performance within the project. So I'm going to hand it off to John here, and he's going to give you some examples within software, so of real-time visualization and comparison between the two.
I'm John Fish, and I have a dual representation here today. I represent Industrial Measurement Solutions, which specializes in bringing value to projects and owners with laser technology. I also represent S&B Engineers and Constructors, where they've pioneered some of the visual things that I'm going to be showing you today. They're pretty far advanced in their ability to take data and make that visual. I'm going to look at two aspects here. The first one is the visual model progress tracking, and that is connecting your model to a database so that you can see where things are visually, making the data visually. Brookshire said that what he wants to see is actionable data, something that's visual, but it's actionable, that I can really go out and do something with. So that's one of the things we're looking at here. The other thing is dimensional control. And dimensional control is something that I don't think has been spent on, we haven't spent enough time on dimensional control, and it can deliver real value. So this is a picture right here of our what we call visual progress model. And again, everybody's stressing the importance of data. It's all about the data. You've got to have clean data. It's got to be the right data, and it's got to be real time or as real time as possible. So you're going to need an asset-centric project information management system that is preferably transactional based. In other words, as you push the button and you issue drawings, deliverables, as you issue a purchase order, as you receive something at the job site, it hits the database almost immediately. And then you can read that, whether it's overnight or whether it's on a weekly basis, and it will actually, your model will turn those assets the color of that particular transaction or milestone. So that's the transactional models. Right next to that, the next thing is to use, and this is where you can use photogrammetry, lasers on a backpack, whatever you want to do. And you're going to look at your 4D model. In other words, you've taken your schedule and putting that into the engineering model. And you can see what you should have done. And then you can actually take the laser or the photogrammetry and overlay that and see what you have done. And if you have the right amount of accuracy, you can not only see, have you done it, you can see, did you do it right? Is it where it's supposed to be? And in many cases, that's a problem. And I've got war stories where they put the cable tray, they got there before the piper did, they put the cable tray on the wrong side of the rack. And you need to catch those things before they get to be too much of a problem. So there's just a couple of examples of using that laser scanning for progress reporting so you can see where you are against the model. Now we're going to start talking about dimensional control. And dimensional control is where you take your laser scanning and you actually go into the field, take assets and take their measurements. You actually go to the fab shop and take their measurements. And what you're really trying to prevent here is to make sure that you have no unplanned events at the job site. Now, this required, we talked about AWP, and the A in AWP is getting up into the front. You need in your risk assignments, your risk management, you're going to need to look at where have I got risk? And let's just say I've got some high chrome pipe, and it's a 36-inch diameter, and it's going to be coming off of a tower, and it's during a turnaround. What's the chances of that pipe not fitting? So it's going to be a huge impact on the project. Things of that nature. So you look for what you call high-risk items. What's the impact? Can I do to mitigate it? And dimensional control is one of the elements that you can use to mitigate that. Let's talk about unplanned incidents for a minute, because I've got a story, and this just happened to me. But my wife says the light is out in the ceiling fan. Not a problem. We'll schedule a project. I'll do it first thing in the morning. I'll get my little safety ladder and go out there, and I did. I got my safety ladder, got out there and climbed up, and I untook the little retaining clip, and I gently brought down the bowl, and I handed that to my wife so that I wouldn't inject myself, going down the ladder and everything. I did it safely, and she took that, and then I got up there and unscrewed the light bulb, and it's got one of those miniature sockets on it. I didn't have a light bulb with a miniature socket. I own my regular light bulbs, So what do? Unplanned event. I get off my ladder and I drive down to Walmart and I try and buy the light bulb that come the closest. They didn't have an exact match, but they had something that looked pretty close, so I bought it. Got home, got back up on my ladder again, we screwed the light bulb in. It went in fine. Everything's going good. I put the bowl up and it won't fit. And I kept forcing it, and it won't fit. So I said, well, I'll just get the retaining clip, and I'll just screw it up. I don't know what happened, but I dropped that little bolt, that little nut, retaining nut, and in its panic, I tried to grab it, and instead I grabbed that little pull chain you got on the light, ripped it out of the socket, totally ruined the lighting fixture. So end result, I had to go to Lowe's the next day, buy a new ceiling fan. And then my wife said, you ain't putting that thing up here, not after what I saw you do the last time, So then I had to call Home 360, to go put my ceiling fan in. So $400 later and 4 days later, that 15-minute job got complete. That's the impact that an unplanned event can have at a job site, almost a disastrous. So that's what we're trying to prevent. This is really serious stuff, guys. Here's a place where we've got a scrubber tower. We've kind of scanned some stuff there. And if you look at that thing, you'll see where these things are the dimensions are off a little bit. Everything not quite where it's supposed to be as it was designed. Not a problem as long as I know about that in advance and I can adjust for that or I can mitigate that. There's a flange coming up here. Here's a flange that somehow it got rotated 7/8 of an inch. Everything looked good, but when you take your laser scan and you put that into your model, you do a virtual assembly, you say, uh-oh, something's going to be wrong. We caught this one before it left the fab shop. They had to literally cut that flange off and scoot it over again. So these are the things you're looking for. And you don't want these things to happen, especially if you got a crane or a lift involved. You don't want these things to happen to you at the site. Here's a case where we had two modules coming together. We scan them, and you're looking at the fit. They're not going to fit, but we kind of know that. We can accommodate that, or we can make the mod shop do some modifications there. So the thing of it is to identify your risk, take the mitigation steps to make sure, go to the fab shop, go to the field. A lot of times we'll laser scan anchor bolts to make sure things are going to fit in the field. This is the big guy right here. Here's where we're actually pulling a huge reactor out, and then we're going to bring a new reactor and set it in. So we went to the fab shop, we scanned the new reactor, we scanned the existing reactor and the towers around it, and we did a virtual, let's remove that thing. And in the removal process, we saw everything that is going to hit, everything that has to be removed ahead of time so that we can do that safely, and if anything has to be braced, et cetera. Then we took the new exchanger, took the scan of that and did a virtual lift and set it in. And we found out more things, because the new exchanger was bigger than the old. It's a reactor, I said. It's a reactor. So we took the new reactor and we virtually set it in, and there's even more things that had to be taken out in order to set that. Not only did it have to be taken out, but we found out in the virtual that we had to bring it in and rotate it a little bit and bring it down and then rotate it back again. So all this was planned out. We knew about it ahead of time, and it's in the plan. So that's what I mean by using laser technology to prevent unplanned events. By the way, there is being from Louisiana, I'm going to have to slip this one in. But you get into how accurate should your laser scanning be. Well, in this case, we're talking plus or minus a 16th of an inch. But and it's got to be pretty close, and the Cajun ruler won't work. For those of you who are familiar with the Cajun ruler, in Louisiana, you can't say that a fish is this big. You got to tell them how big it is with something they can relate to. And we have an inch, we have a 1.5, a 2.5, and a 3.5. And a 1.5 inch fish is 1.5 Bud Light cans. 2.5 Bud Light can. Everybody knows how big a Bud Light can is, so that's your measurement accuracy. With that, I'm going to turn that one over to you, Andrew.
Okay, mental note next year, don't follow John Fish in the presentation. I don't measure things in Bud Light cans. But, so my name is Andrew Foy. I'm with O3 Solutions, and I should probably step this thing on. Is that the button? Okay. So I get to finish this off, and I'm going to be talking about what should be visualized. So when we're talking about real-time progressing and visualization, what are we actually looking at? I'm sure many of you have heard the expression, a picture paints 1,000 words. So what I'm trying to do here is not include words in these slides and just have pretty pictures. So we can use the 3D model, as Jonathan already alluded to create a construction-centric view of what's going on in the project. The one I always start with is these things can be forward-looking or backwards-looking. And the first one I always want to look at is the forward-looking. This is going to be telling me something that's going to happen in the future, and I want to know what's going to be a problem. Kevin Nally, I believe, already alluded to this yesterday, something like constraints. What do we have and what do we not have? I remember 10, 12 years ago working at a fab shop up in Canada, and a client marched into the meeting and was saying, "Why haven't you started welding yet? We've given you 80% of the material." And we're sitting there frantically flicking through these big reports and Excel spreadsheets and all this, trying to figure out the problem. And the problem was exactly what Kevin alluded to yesterday. Yeah, you've given us 80% of the material. You've given us all of the straight run. You've given us none of the fittings. What would you like us to fabricate for you? But we didn't have something like this where you can pull up a very, very simple image on the screen, and if half of it is red and half of it's green, you're looking at everything saying, what do you actually want me to build? So constraints can be, do we have the drawings? Do we have the materials? Anything that we can pull information from somewhere else, we can take your drawing log, we can take your material register, pull all that in, instead of you flicking through hundreds of pages of reports, picture it right on the screen in front of you and see it in a way that's much, much easier to consume. Second one, fabrication. Fabricators, and for the love of AWP, you'll try and tell a fabricator, this is exactly the sequence we want you to build this in. You know, we want you to build module 1 first, and then module 2, and then module 3, because that's the sequence we're going to install them. And then you're going to walk away and think they fully understood exactly what I wanted, and they're going to build it exactly in the sequence I've asked for, right? I think it was one of your presidents that said, trust but verify. So this is that verification step. I want to be able to take a fab tracker report, whether it's something as simple as pipe fab or steel fab or module assembly, take one of those Excel trackers from a fabricator, and again, instead of having to figure out, well, this thing is 36% and which ISO is that and all this, pull that in, load it up into the model, and immediately I get a picture. So just looking at this hilarious mishmash of colors here, what am I going to be able to actually do with anything that they're sending me there? There's very little of any of that I'm going to be able to build because some of it's ready, some of it's still in fabrication, some of it's on its way to the paint shop. I don't have anything I can actually realistically do. And too many times, as I'm sure you've all seen, we start work, we go out to the field, we get going because there's so much pressure. You've got some spools, get welding, get going, get started. And then 2 days later, you realize you haven't got enough to keep you going. So this is another one, and this isn't really real-time progressing in visualization, but it's certainly on the visualization end. We use the 3D model for something as simple as daily meetings. So I'm a big fan of 3 o'clock in the afternoon, 15 minutes, stand up, daily meeting, everybody come in, quick chat about what we're working on, what we're doing, where we're gonna be, what work fronts, what are the problems, what are we missing. Nobody ever sits down in the chair, quick chat, get on and get going. But one of the things we want to look at is, where are you working? What crews are working? What have you got going on? And something as simple as, take this, and this is essentially a freeze frame of a 4D playback, and say, and this could be for today, this could be for next week, for next month. What are we going to be doing? Do we have, for example, somebody installing cable in a tray, and you've planned to have a crew welding pipe directly above them? Again, very, very difficult to picture that and understand the mechanics of it. The piping guys are saying, you've told me I need to install pipe. I'm going to be installing pipe. The cables, the Sparkies are saying, I need to pull cable. Who gets precedence? How do you know that those people are going to be working over the top of each other? So again, very, very simple. You've got your model. You've planned out your IWPs. You've got it all sequenced. You can look at this against the Gantt view, overlay it on the model, and say, hang on a sec, something's not right here. We're going to have ants in a hill. We've got too many people in the same space, and then you can adjust the plan. Installation progress. So this is the one that's normally the sort of, the most obvious of the StatViz kind of pictures. You take an image of your entire site and you colorize it to show progress. One of the keys with this, well, two of the keys with this. Firstly, I'm a big fan of, if you include an image like this on the front of your progress report and send it to the management in head office, they don't need to come to site and look. They can just leave you alone. But more realistically, using this as, again, trust but verify. The contractor submits their progress. That progress gets absorbed and put in against the IWPs. You turn it into this colorized model. I don't need to go out to the field with an armful of reports and drawings and marked up anything. I can take a 3D image of the work, and without knowing the names or physical tag numbers of any of these items, I can look at it in a 3D space because I can see that what that looks like that thing that's in front of me. And this thing's green, which means it's 100% complete, but hang on a sec, there's still bolts missing from that flange. You do that 2 or 3 times, wander back into the contractor's office and say, guys, you've claimed this to be 100% complete. There's a few things missing. The minute they know you're paying attention, and the minute they know you've got the mechanism at a detailed level to pay attention and check what they're doing, immediately the level of accuracy of reporting increases because they know they can't pull the wool over your eyes. Simple as that. Another one, and a really, really good one, especially for pipe, what I'm calling here multi-phase. So you've got a piece of pipe in the model. So you use that as a representation of piping installation progress. You can also use it for other things. So what do we have to do with the pipe? We have to install the pipe. We have to then, well, depending on the sequence you're doing it, either hydrotest it or paint and then paint the welds, or vice versa if they're letting you get away with painting welds before you hydrotest. And then I spend a lot of time up in Canada, probably doesn't apply too much here, but electronic heat trace. I guess the weather down here doesn't make that too much of an issue. And then insulation. So you can use the different colors to represent the different phases of completion. So one color means I've installed it, but I haven't yet tested it. Another color means I've tested it, but I haven't yet painted it. Another one means I've painted it, I haven't yet heat traced it, et cetera, et cetera. And the beauty of that is the colors very, very simply mean that is the backlog of work for the next crew. So if, in this case, blue represents it's been tested, but it hasn't been heat traced or it hasn't been painted, if I've got a sea of blue on the screen, I'm going to be calling in my painting foreman and saying, we need more people on site, why aren't you keeping up? Very simple, very easy to understand. I don't need to be taking reports from 15 different people and comparing them. Suck it all in, visualize it right in the model, and get a very, very good picture of where we're at. And the last one, turnover. We want to keep doing bulk construction for as long as practical. Everybody argues over the whole, is it 60%, 65%, 70%, 75% when you try and transition over to that point where you're doing system-based finishing construction. Biggest issue we normally find is lack of information. Where are we with this system? We need to turn over this particular system 6 weeks from now. Is it ready? Are we done? We need to be able to pivot our view to be able to say, I want to isolate just on this one system, look at this and say, am I going to be ready to meet my contractual commitments? So you can continue on your work. This could have elements of 10 different IWPs in it. And if you realize then that that color scheme means, no, we're not going to be able to meet the date, you can pull those elements out of whichever IWPs they are and prioritize them for additional, put them in a priority package to make sure they get done in time. So simply put, like I said, picture paints 1,000 words. There's a lot of good ways that we can use the data without having to get an army of people typing things in. Take the data that you've got and use it to give you a lot of good information. So that being said, we are now going to take a slightly novel approach to kicking into the Q&A section, which is we are giving away a TV and a cooler, mostly because it costs more to fly them back than it does to leave them here. So to kick off the audience participation part, if anyone has any other good uses for StatViz, colorized versions of the models, grab a mic, put your hand up. The first 2 people, one gets a telly, one gets an Igloo cooler. We'd love to hear some good ideas. That cooler has 4 beers in it. There you go. Oh, but it's Miller Lite, so,
Okay.
Yeah, there you go. Yes, yeah.
Should we go hot on the mic?
Hello. Subcontractor, sorry.
Hey, Mark. Okay, there you go.
Hey, Andrew. Subcontractor status. So for heat trace, insulation, painting. So getting that from the subcontractor, not just directly from your contractor, but subcontractor information from Excel spreadsheets that are less scientific than some of the other information that we have.
Excellent. So you can go and see Tori at the end. Let her know if you want a cooler or a TV.
Tori is suddenly my best friend.
Anyone else? We got one hand up down here. Oh. Whoever's got the microphone.
I built one for module install, so you had over the different weeks when that module was installed.
Yep.
And as you progress, you kind of change the colors so you can see what's coming, what's installed, and then what's next, or what's done. And you kind of take snaps of that, put it into a presentation, and you could easily snap through it real quick. So it's kind of a poor man's 4D.
Flickbook. Love it. Good stuff. Any more for any more?
Yes, sir. So we're
Sorry,
looking at,
Lloyd, you're getting your steps in today.
backing up a little bit from construction, but going back to just the engineering phase, the status of a module design-wise, is piping complete, structural steel complete, are the components, the tag components purchased and on order and on schedule for delivery, so you can see your status of that before you turn it over to your modularization fab company.
Absolutely.
One addition is
Sorry. We had a sequence here already. Go ahead, Lamar.
so from the construction side, additional like lube oil flush or chemical clean, so you actually can highlight that in the model and show everybody, okay, what are we going to be lube oil flushing or chemical cleaning from that standpoint? So that works pretty well.
Excellent.
Good. So I guess a good idea for me, and kind of back to Bill's issue earlier, a way to highlight systems that have been sold to quality control and quality assurance, which initiates real release of work to the Softcraft.
Okay, lots of good ideas. So like I said, that was just the transition into the Q&A, so I think now we're ready for Q&A. If anyone else has any questions, I'm going to go and sit down.
Okay. Questions? Oh, sorry. Thank you.
Frances Malinchuk from Wood. Since you touched on dimensional control and laser scanning, and you're also touching on 3D visualization within O3, has there been any way of combining those together and having that additional information in O3, or how do you see that those two could work with each other versus bouncing back and forth between a laser scan and O3 and models? Thank you.
Yeah, so that data can be pulled in, and overlaid, as long as we've got an ability to mirror the dimensions of the laser scan, we can pull in the laser scan information or the dimensional control information and overlay that. I suspect that your dimensional control already has model viewing capabilities. But yeah, within O3, we can pull in the laser scan data, for example, and overlay that directly on the model.
So part of the name of this presentation is real time. So, and that's kind of we found when people use that word, it can almost be a dangerous word. How real time is real time? So how close are we to saying a spool's installed and we can call up the model right away? So that's something that we often update once a day, but some clients ask for real time, and that can be a difficult question to answer.
Yeah, if I understood it right, and you're right, it's near time, and you have to define what near time means. In some cases, near time is overnight. In some cases, it's on every Friday. You know, whatever near time means to you. What you don't want to do is be managing from a rear view mirror. You don't want to find out what you did 2 weeks ago, because now you're really in trouble. So I think the goal for all the AI and machine learning is real time would be as close to real time as possible, like almost instantly. That's what we want, but there's a lot of technology gaps before we get there. So I think, overnight is probably about as good as we're gonna get for a while. Make sense?
Oh, over there.
So the idea of using that visualization out in our material yards is really interesting. You've represented this visualization only at the work phase, but when we take a look at our supply chain, I would be really curious to see if you could replicate that, where that spool or that structural steel lies in the middle of hundreds of acres of laydown space that we never talk about in these projects.
Well, I'll try and have a go at that one, especially because I spent a number of years in Canada. It's also, suddenly it was there yesterday, and now there's a foot of snow over the top of it. So yes, there are tools and software out there that deals with that kind of location-specific laydown pattern, where things are placed, how things are managed. I don't know that any of them are actually here today, but there are tools and systems that do that and can manage it based on, yes, it's received. Something as simple as an RFID tag on a truck that's tied to the inventory of the truck. So as it drives through the gate, you instinctively know that it's on site. That clears the constraint. So we can receive that kind of data within our system from that tool. And then you can have active tags and passive tags to be able to locate physically. You can have, I believe you can even have little robots that drive around the facility and scan those tags to be able to understand exactly where everything is from 1 minute to the other. Hopefully that answered your question.
Which is the tool or the strategy to get the field data in the system within the day?
Can you just repeat the question?
Yes. So we are talking about progress real-time representation in the system. So it is supposed that the data from field come in the system real quick, in a fast and in a fast way. What is the strategy to bring the field data in the system? The progress
for sure.
data.
So there's a few different methodologies for that. It could be taking a photo of the actual piece of equipment with the tag, and then geolocate it within your plot plan of your project, and that would feed data into the real-time visualization to show different earned value statuses. It could be an API through an RFID tracking program where it gets scanned. It's now gone from the supplier to site. It could be site verification where you're using an iPad and you're manually changing the progress, whether it's material, procurement status, system status, or any other type statuses you would be using on the project. So multiple methods from the old school Excel to physical media to an iPad or digitally scanning it, or even a reality picture where AI can identify that this device is on site and it's ready to be verified to the next step.
I'd actually like to ask a question. I don't usually do this. And it's different than what you might think. What is the cost of not having real-time visualization and progressing?
Well, I think anyone who's ever been on a project that's gone sideways could probably share the pain story of that would answer that question for you. I heard, and again, my apologies to the CII team who actually wrote this, but if I remember the exact stat right, something like 70% of projects only report deviation from plan, from baseline, at about 70% complete. So just think about that for a second. Most projects have this blinkered approach. Everything's great, everything's great, everything's great, oh no. So to answer your question, what's the cost of not doing this? Well, as somebody already alluded to, if it takes 2 weeks for you to find out, it's probably too late. You run cycles on project reporting. Too many times I've sat in progress meetings. So the contractor submitted their report on the Monday for the previous 2 weeks of work, and we're talking about it on the Wednesday. That could be 2.5 weeks after the thing has actually happened, and we're just sitting there talking about it now. So by the time you're talking about it, it's already happened, it's already been a problem, something's already taken place, and now we're in recovery mode. So what's the cost of recovery? I mean, it's quite simply, it's one of those things where it's the same old adage, $1 up front saves 10 on the back, normally.
Hey, Andrew. I'm Jay.
I thought I was getting away there.
Yeah. To help answer that question, I mean, it's a great one, right, Lloyd? But using the model and showing what they just showed through the likes of an O3 or through any mesh model as far as that goes is great information. And it's what you planned, right? So you tie your schedule to the model. It shows what you're going to be doing. It becomes four-dimensional. That's really wonderful information. But we have a lot of tools and capabilities beyond that we can use to validate, did we do what we thought we were going to do? And there's tools like Verum is one company that does it. There's a couple more. Anyway, backpack cameras, people walk around and all they're doing is walking around with a backpack camera on, and it's recording everything that they're doing. You can take that information, you could overlay it right against what you said you thought you were going to do. You can have the mesh model here, you can have the pictures here. It can be video, you can use drones. We have drone imagery where we can look at it even with the drones, and they're high resolution, all attached to a GIS coordinate system. So when you talk about real-time progress, that's real-time progress, looking at it live. And we were actually got to the point where in a portion of the unit we were piloting this effort, we were paying the contractor basis that information and not basis what the rules of credit that we had established with them were, because it was that accurate. You couldn't argue with it. So if that's valuable to you, then you might want to try it.
So one other question I have for you. When you're getting this information, what's that going to mean for the processes that the companies had before? So if you're used to doing turnaround in 2 to 3 weeks and you want to change it to 24, 48 hours, can you still use the same processes? Do you have to redesign the work processes? How's that work?
Well, it depends partly what it is. I mean, some of the stuff we were showing, for example, is, progressing. So progressing in IWP, what we're really talking about is instead of an old school system where you had a spreadsheet and you updated it and then That was your progress report. At the end of the week, somebody calculated earned value off that spreadsheet. You're literally now going into the system and there's a grid that says, here's the spools or the ISOs and here's the steps. Have you done this? And you check, 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 check. And then in the background, the system calculates based on all of that and the values that are in there. Here's your own value. So does it change your process? Yes, in the sense of how you're going about achieving it. The best thing that it can be is not extra work. Because the minute it's extra work, people will find a way to get out of doing it. But the minute it's baked into what we're doing, we build our IWP, we remove our constraints, we get it approved, we go out and execute in the field, we track its progress, we close it out. As soon as it becomes a function of how you're doing that, the digitalization part of it, this becomes the pretty pictures become something you get out of it simply by doing it, not the intent on their own. So we're not doing this to generate pretty pictures. We're doing this because by managing the IWPs or the work packages in general, the XWPs, we can use that data to then create the pretty pictures that can tell us the story that we need to understand where to put our time and our effort.
While you guys were talking, I just remember a little story. I read the book Taipan just recently. Is anybody familiar with the book Taipan? It's the founding of Hong Kong. And the Taipan was the richest businessman on the island. And what he did, he bought a house on the highest part of Hong Kong, where Hong Kong is today. And the reason he did that is because you got to remember, this is 1840s, and it's all sailing ships. They didn't have any other kind of ships, just sailing ships. And from London to Hong Kong, I think was a 6-month trip, something like that. So the newspapers they got in Hong Kong were roughly 3 to 6 months old. And that's where the business was for the traders. They had the trading markets and all that. And the guy bought the house on the very top, highest part of the hill, so he could see when a ship from England was coming in the harbor, and he would send his men out there to get those newspapers before his competitor did, so he could bring value to his business. And I think it's the same thing. It's all about the speed of information. How quickly can we get the information to the people who really need it to make the decisions to bring value to the project? Does that make sense? Okay.
Pardon me?
And it better not be 6 months either.
Sorry? Oh, sure. Go ahead. Just curious, do we have, show of hands, how many owners do we have in the room? Okay. And if one of you is willing, I'd love to hear what you think this would do for your organization if you could get more real-time progressing. So obviously everybody's opinion matters, but who pays for everything? The owners.
Yeah, one of the examples you did indicate that once you get an update on the actual P6 file, it's probably 2.5 weeks late. I think Andrew mentioned that earlier, right? Well, the problem from an owner's perspective is if you add all these delays up, by the end of the project, you turn it to commissioning and handover, the project schedule could be a month, 2 months late. For the owner, that's a free cash flow problem. That's money. That's additional revenue that we can actually gain. So for every potential risk that we can't identify early, it's going to keep adding up and adding up and adding up. And then ultimately your NPV for your investment is not as good as it is. So huge point there.
Anyone else like to add their thoughts? Of course, other side of the room. I don't know about the rest of you, but I'm getting my steps in.
Hey there. I got a question. So how are you dealing with a lot of the time commodities like cable tray, pipe doesn't have the break of where it actually is being installed to. Sometimes steel, you have tall members of steel where there's a splice, but the model is still just a single piece. Are you working with the engineering side to make sure that you can be able to break those items based on, say, installation progressing?
So the construction model is largely going to be based on the original engineering model. Now, you can overlay additional information, so we can overlay like pipe fabrication data, steel fabrication data. So if, for example, in the example you gave about steel and splicing, as long as that's captured in the fabrication data, we can basically replace what's in that original 3D model with what we know is coming to us, which is the stuff from the fabricator. And then that way, instead of having one big column with no splice in the middle, we can replicate and say, this is exactly what we're then going to have to install. So, but it does rely on that downstream data. I mean, these construction models exist because somebody else has done the design, has put the attributes in there. We had a conversation earlier today about field world locations. You know, do you let your fabricator just decide where to put the field world locations? And again, I mean, most of the time you don't, and there's very good reasons why you don't, but we can take the data from the fabricator, and even if that replaces and supersedes what's in the original engineering model, you can overlay that and use that as the new coordinates.
Okay, so if there's anyone who's got a burning question, this is a good time. Otherwise, I will thank the panel, and I've got a video for you. So come on, last chance. No? Okay. Want to thank the panel. Very informative, and I've got to share an anecdote with you. I've been involved in the development of work-phase planning forever ago, and I was on the research team that did AWP RT272. I want you to look around this room. You see all the technology suppliers that are here to support AWP? When we first came up with work-phase planning, virtually none of them existed. Now, you can't even imagine not having them. And the opportunity, I think it was Jay that said, you know, what do you think about the 10% reduction in TIC and the 25% reduction in labor? I think with the technology we have, with the knowledge we have, that's a low bar. We can do much, much better. And I'm going to thank the panel, and I'm going to show you a video right now. Thank you so much.